Okay, we are in the last lesson of this week, for week 3. We're going to relate the standard and factored forms again, so this is part 2 of the lesson. What I'd like you to do is take a moment to review the investigation from the first class in this unit. How were the x-coordinates of the vertex and the equation of the axis of symmetry related to the standard or factored form of a function? So pause the video and take a look. Well, when you examined the investigation, you should have remembered that the x-intercept of the vertex, which is the same number as the value for the equation of the axis of symmetry, is right in the middle of the two x-coordinates of the vertex. So it's the mean of the x-intercepts. So again, to find that axis of symmetry, actually, I can use an X here, or I could use an H. I think I'm going to change it to an H. We take our two x-intercepts, R and S, we're going to add them together, and we divide them by 2. Because they are always in the middle of the two x-intercepts. So the x-coordinate of the vertex and the axis of symmetry is always right in the middle. And again, this formula gives us the mean of the x-intercepts. So let's do example 1. For the function 2x squared minus 5x minus 12, it says determine the zeros, the equation, and the equation of the axis of symmetry. Okay, to find the zero of a function, we set y, or f of x, equal to 0 and solve. Once again, I want you to use the factoring chart. So I'm going to let you continue, so pause the video and factor this. Okay, so you should have realized that in order to factor this, we are going to use decomposition. And in decomposition, we're looking for factors of -24 that sum to -5. And the numbers that work are -8 and 3. So you should have had this done, or something like it. You may have put the -8 and 3 in the opposite positions as I have. At the end, it won't matter. We'll get the same answer. Okay, so I'm in that common factoring step of decomposition. And then I factor again. So I have x minus 4 times 2x plus 3. Okay, so that was all the work for factoring that by decomposition. Okay, we're not done though, because we were asked to find the zeros. So there's step 1, step 2, step 3. We set each of the factors equal to 0 and solve. So this gives me 2 zeros of x equals 4. And when I solve this one, I get x equals -3/2, which is the same if you want to work with the decimal value of x equals -1/2. Okay, so I know that the equation of my axis of symmetry is going to be right in the middle of these two values. To find that h value, or the h coordinate of the vertex, which is the x-coordinate of the vertex, I'm going to add together 4 plus -1.5 and divide that by 2. So that gives me 2.5 divided by 2, which is 1.25. All right, so next what we want to do, oh sorry, I want to do one more thing here. So my equation, the axis of symmetry, is x equals 1.25 because it's in the form of x equals h. So this is my axis of symmetry. That's its equation. So the next part says to sketch the graph and label the points determined in A. Use Desmos to find the vertex. Okay, so I know that my zeros are at 4. Let's just say that's 4. And at -1.5. And I know that my axis of symmetry is right in the middle of those two values. So let's just say it's here. Actually, that doesn't look like a good spot if that's 4. My scale seems off. It is just a sketch. Okay, that looks a little bit better. So what I know is that my parabola opens up because my a value is 2. And I know that it's going to go between -1.5 and 4. But what I don't know is how low to draw that vertex, right? The axis of symmetry has to be in the middle of the two, so it's somewhere along here. So what I'm going to do is I'm going to use Desmos to figure out the vertex. I'm going to use my graph. Okay, so I typed out my equation in Desmos, and I'm looking for that y-intercept, or sorry, not the y-intercept, I'm looking for the vertex. And I can't see it, so I want to adjust my viewing window. My lowest y value there was -20, and that's not enough to see it, so let me change that to a lower number. So let's try -25. Okay, so now I can see it. And then just click on that to see the vertex. So you can see that we did have the correct h value. The x-coordinate of the vertex was correct, 1.25. And the y-coordinate of the vertex is -15.125 using technology. So I'm going to go back to my graph, and I'm going to sketch it out. And this is just a rough sketch. It is not accurate. I've labeled my two x-intercepts, and here I'm going to label the vertex, which is 1.25, -15.125. There's the y-coordinate of the vertex. And I'm also going to label the axis of symmetry, which we found earlier, which is x equals 1.25. Okay, and if you prefer to use fractions, that's great. Put in your fractional values instead of the decimal number. Does this function have a maximum or minimum value? Well, we can tell from our original equation, because a is positive, that it was going to have a minimum value. And it's the y-coordinate of the vertex which is giving us that minimum value. So it has a minimum value of -15.125. So basically that means, what is the lowest value on the graph of this parabola? The lowest value, the lowest number will be at that vertex when it opens up, and it's -15.125. So to summarize what we've done in the last couple lessons, R and S are the x-intercepts, or the zeros of a function when a quadratic function is expressed in factored form, which looks like this. The axis of symmetry is the vertical line that runs through the vertex. Its equation's defined by x equals r plus s divided by 2, where r and s, remember, are the x-intercepts. This equation also gives us the x-coordinate of the vertex. To find the y-coordinate of the vertex, if you want to do it algebraically, and doing it algebraically actually is not going to be an expectation for distance learning. It would have been if we were in class. So if you do want to do it algebraically, what you need to do is substitute the x-coordinate of the vertex in for x in the equation of the function, and then solve for y. Okay, so to make things a little bit easier, what we're going to do is we're just going to use Desmos to find the vertex. The value of a in both standard and factored forms tells us the direction of opening of a parabola and whether the parabola has a maximum or minimum value. So once again, the two diagrams that help with this is we can see that it has a min when a is positive. Okay, the i's tells us the a values. And we can also see that it has a max when a is negative. All right, let's do the example on the back. Actually, this example on the back is really a practice question for you. So again, read the question, underline it, try it on your own, pause the video, and then when you're ready to take up your answer, resume the video. All right, the practice question says the height of a rugby ball kicked from the ground is given by the function h of t is equal to -5t squared plus 20t, where h of t is the height in feet and t is the time in seconds. And it's asked us to determine the zeros of the function. So step 1, we set what's equivalent to y equals 0. There's step 1. Step 2, we solve by factoring. Use that factoring chart. So we're going to factor out a negative 5t. I can common factor here, and I'm left with t minus 4. That's step 2, the factoring. Step 3, we set each of these factors equal to 0 and solve. So the only way this statement could be true, to multiply two numbers together to get 0, is if either negative 5t equals 0 or t minus 4 equals 0. Okay, so when I divide both sides by negative 5, I get t equals 0, and here I'd have to add 4 to both sides to solve, and I get t equals 4. So here are my two zeros. B says to make a sketch of the graph, so while I'm doing my work here, I might as well find the equation of the axis of symmetry, which would be the same as the x-coordinate of the vertex. So I'm going to add my r and s values together and divide them by 2. So I know that x equals 2. That's the equation of the axis of symmetry. All right, so our sketch. This is a more realistic problem. So when I do this question here, I don't need all 4 quadrants. Here we have the time in seconds, and here's the height in feet, and it's just a sketch. So what I do know is that my two x-intercepts are at 0 and 4, and I know that the axis of symmetry has to be exactly in between. So that's the line x equals 2. And I can tell by looking at my equation that my a value is negative. That means the parabola is going to open down. So I'm going to just draw a rugby ball going up in the air. Its maximum is going to be somewhere along that line, and then it's going to come down again. If we want to know exactly where it is, I did mention that using Desmos is fine. You could type out this equation in Desmos and then read the vertex. But for those of you who are interested in finding it algebraically, this is what you do. After we find the x-coordinate of the vertex, or the value for the axis of symmetry, we take that number, so in this case it's 2, and what I want to do is I want to evaluate the function at x equals 2. So using function notation, it looks like this. I am finding h of 2. So remember h of t, if I look at my equation up top, says negative 5t squared plus 20t. So what I'm doing then is I'm substituting 2 everywhere where there's a t, and I'm evaluating. Okay, so let's work this out. So 2 squared is 4, and 4 times 5 is negative 20. And this part would be 40. So negative 20 plus 40 is positive 20. So I actually know my vertex. The vertex is at 220. That's the vertex. So I can do this algebraically as well. But once again, it will not be an expectation in distance learning. You can find this value, this particular part of the vertex, using technology. So what did these zeros tell you about the rugby ball? Well, it tells you when the ball is on the ground. So we know that the ball is on the ground. At 0 seconds and at 4 seconds, which means it takes 4 seconds for the ball to land. So it takes 4 seconds for the ball to land. Looks a little bit messy. I'm going to fix that. Okay, and what does the vertex tell you about the rugby ball? Well, the vertex tells us that at 2 seconds, the ball reaches its maximum height. I'll just move that up a little bit. So at 2 seconds, the ball reaches its maximum height. It also tells me the maximum height. So I can see that this ball reached a maximum height of 20 feet. So the ball reaches a maximum height of 20 feet. Okay, so let's take a look at what the vertex tells us in general. So here's my vertex. This always gives you a max or minimum value, which is the y-coordinate of the vertex, the x-coordinate of the vertex, which I sometimes refer to as h because in Unit 2 we use the letters h and k to represent the vertex. So the number 2 tells you when or where, depending on the situation, the max or min occurs. I just want to explain something that comes up in the homework just to make sure that everyone understands it. So that's the end for this part of the note. You might want to jot the next example down as well though. So if I ask you to solve this particular quadratic equation, x squared plus 3x equals -2, you can't solve that by factoring right away because this equation is not set equal to 0. So you have an extra step to do in questions like this. So again, if the instructions were to solve, find the roots, etc. So we want to start by moving that -2, or whatever you have on the right side. We want to move it all to one side. So in this case, I'm going to move everything to the left side. So now I have x squared plus 3x plus 2 equals 0. So move it carefully. It moves because I'm going to add 2 to both sides. -2 plus 2 is 0. And now I can solve by factoring. So now I have a trinomial where a is 1. I'm going to factor quickly with my chart. I'm looking for factors of 2 that sum to 3. The numbers that work are 2 and 1. So this factors to x plus 2 times x plus 1 equal to 0. And then I set each factor equal to 0 to solve. And I get x equals -2 and x equals -1. So I cannot solve by factoring without doing this first step. The equation must be set equal to 0 to start with. Because this method, the only way to solve this way is we have to use the zero product property. So that's when we have two factors that are multiplying together that give us 0, or two numbers, because these just represent numbers. The only way this statement can be true is if one of the numbers, so either the x plus 2 or the other one, the x plus 1, has to equal 0. And that allows us to do this next step. Okay, so this is really, really important. It does come up in some of your homework questions. So if the equation is not set equal to 0, you cannot solve by factoring. You must move all terms to one side of the equal sign before you begin. Have a good week, everyone.